In the previous video, we talked about the concept and the need for a mole, and let's talk about what you can practically do with a mole. So the mole is going to be the basis for a lot of our calculations for yields, limiting reagents, things like that. So we're going to put this at the center of a map here. So this is our mole. Now there's two things you need to be able to go to when you work with a mole. You need to be comfortable converting back and forth between mass and moles and numbers. So numbers of atoms, numbers of molecules. Now, first one, practical one, is conversion mass, because this is what we measure in the lab. So if we want to go from mass to moles, we're always going to take 1 over molecular or atomic weight of what we're interested in. So if we have something like fluorine, okay, a single fluorine atom weighs 19 grams per mole, or if we have F2, this is going to be 38 grams per moles. If we have a mass of fluorine, we're going to divide by the molecular or atomic weight, depending on what we're working on. If we want to go back and forth, if we want to go from mole to mass, all we do is multiply by the molecular weight. So two things to note here. Okay, first of all, your conversion factor between mass and mole is going to change depending on what you're working with. So if you're working with something like CO2 versus carbon monoxide, CO, it's going to change what your molecular weight is. Second thing to note is that the mole is always going to be the smaller number. So if you're converting from mass to moles, your number should always get smaller. If you're converting from moles to mass, your number should always get bigger. There's only one exception to this. If you're working with atomic hydrogen, just H, hydrogen arrays 1.01 grams per mole, so they're going to be the same. But in general, use this as a guiding point. If you're converting from mass to moles, you should always get smaller. If you're going from moles to mass, you should always get bigger. Now, converting from moles to numbers. A mole constitutes 6.02 times 10 to the 23rd of something. So if we have a mole of argon, we have 6.02 times 10 to the 23rd atoms of argon. If we have a mole of CO2, we have 6.02 times 10 to the 23rd molecules of CO2. So whenever we go from moles to numbers, we're always going to multiply by Avogadro's number, the 6.02 times 10 to the 23rd. And we go from numbers to moles, we're always going to take 1 over it. Two things to note here. First of all, to go between numbers and moles, the conversion factor is exactly the same. This is in contrast to mass and moles where it's going to change. It doesn't matter what mole you're working with, the conversion factor between numbers and moles is always the same. Second, just like mass to moles, moles are going to be the smaller number. Your moles should never be bigger than 1,000 and less than 0.001. There will be occasional exceptions, but generally this is the range you work in, which is why we picked the mole the way we have. The number should always be some large power of 10, 10 to the 20, all the way to 10 to the 27, depending on what you're working with. So this should be a huge number, this should be a tiny number. Now, next video, we're going to talk about what to work with here. Let's say we want to convert between molecules and atoms and molecules. That is where we're going to do our work here, or we can equally do it here.